We're going to compare prime factorisation of 60 with its factors. So first of all, we need to find all the factor pairs for 60. So we know that we have got 1 times 60 would make 60. 2 times 30. 3 times 20. Remember, I'm doing this systematically. 4 times 15. 5 times 12. And 6 times 10. Okay, have I got all the factor pairs there? We see 7 doesn't work, 8, 9, and then we're back to 10 again, which we've got over here. Okay, so then let's have a look at our prime factorisation. So we could split this, so let's do 6 and 10. Because remember, it didn't matter where we started. Well, 6 is not a prime number, so I can definitely split that one further. So I now have 2 and 3. Now 2 is a prime number, so I'm going to circle that one. 3 is also a prime number, so I'm going to circle that one. And then 10, how could I split that? I could split that into 2 and 5. We know that 2 is a prime number. We also know that 5 is a prime number. So therefore, I have got 2 times by 2, because I'm going to put them into numerical order, times by 3 times by 5. So here we are. I have got all of my factor pairs, and I have got my prime factors. So bearing this in mind, I want to have a look to see if there's anything I notice about the different factor pairs and the prime factorisation. So let's pick one of the pairs. So let's pick the number 20 and let's have a look at the prime factors of the number 20. So let's split that first. So I'm going to split it into 2 and 10. Well, we know that that's a prime number, so we can circle that. So 10 isn't, so I've split that into 2 and 5. I know that 2 is a prime number. I also know that 5 is a prime number. So what are we noticing about these prime factors? Well, I've got 2, 2, and a 5. Now I've also got 2 times 2 times 5 there. Let's bear that in mind and let's have a look at another one. So let's have a look at 12 this time. So let's split 12. I'm going to do 2 times 6. I know 2 is a prime number, so I can circle it. 6 is not a prime, so I'm going to split that again. And I've got 2 and 3. I know 2 is prime. I also know that 3 is prime. So the prime factors of 12 are 2 times 3, which I can also write as 2 squared times 3. And look, up here, 2 times 2 times 3. I wonder if that is always the case. If the prime factors of one of the factor pairs will always appear in the prime factor of 60. Let's have a look at another number. So 30, let's split that one. So I have 3 times 10. Remember, you don't have to split them like this. I know that 3 is a prime, so I'm going to circle that. And I'm going to split my 10 into 2 times 5. I know that's a prime, and I know that's a prime. So I know that 30 is made up of 3 times 2 times 5, or 2 times 3 times 5. So we've got 2 times 3 times 5. Okay, so let's have a look at all the ones that we've already explored. So they were the 3 different numbers that we looked at. And I've written down here their prime factors for each of those numbers. So let's have a look at the first one. So we could see that the prime factors of 30 were also in the prime factors of 60. We also noticed that the prime factors of 20 were in the prime factors of 60. And the same for number 12. Does this always happen? And why do you think that would be the case? Maybe you want to try another number just to see. If you go and complete the worksheet with this assignment, you can explore this a little bit more.